there is little or no rigorous evidence that rising concentrations of carbon dioxide are causing dangerous global warming and threatening life on the planet. Arguing for the affirmative, Craig Idso. Craig, please come to the stage. Arguing for the negative, Jeffrey Bennett. Jeff, please come to the stage. Well, both debaters will be using displays, and that's why we've got that up at the screen. And they've all been instructed on how to use the clicker. I think it'll go well. I trust you'll be able to see the displays from the back of the audience. And Craig, you will be speaking for the affirmative, so please come to the podium.
Okay, great. Good evening. It's a pleasure for me to be here, and I would like to thank the Soho Forum for sponsoring this debate. In arguing for this resolution, I want to make it clear from the outset that there is no debate whatsoever as to whether or not atmospheric CO2 or carbon dioxide is a so-called greenhouse gas. When present in the atmosphere, this one carbon and two oxygen molecule indeed has the capacity to absorb infrared radiation and warm the planet. There is also no debate as to whether or not the concentration of atmospheric CO2 is rising. Over the past 2 centuries, it has increased from a meager 0.028% of the atmosphere by volume to a still meager 0.041% today. Furthermore, there is no argument that global temperatures are warmer today than they were 50, 100, or even 200 years ago. The topic or question which is open to discussion, however, and for which we are all here this evening, is whether or not the modern increase in atmospheric CO2 has caused or is presently causing dangerous global warming. Warming so severe that it is threatening life all across the planet. Supporters of the dangerous CO2-induced global warming hypothesis, whom I will hereafter refer to affectionately as climate alarmists because of their concern or alarm about this issue, typically cite the high degree of correlation that exists between historical proxy records of temperature and atmospheric CO2 as empirical support for their thesis. And to that end, you have all likely seen some version of this figure, which displays historic temperature and CO2 reconstructions from the Vostok ice core in Antarctica for the past 400,000 years. Now, given the strong relationship that exists between these two variables, showing that higher levels of atmospheric CO2 coincide with warmer temperatures, while lower levels of CO2 correspond with colder ones, climate alarmists make the inference that changes in atmospheric CO2 caused the historic changes in temperature. And because atmospheric CO2 is a greenhouse gas, they thus contend that any rise in CO2 beyond the upper bound of its historic concentration of the recent geologic past will unequivocally cause unprecedented global warming. Furthermore, they opine, as noted in the recent Paris Climate Treaty and elsewhere, that such warming becomes dangerous when planetary temperatures reach a threshold of 1.5 degrees Celsius above pre-industrial values, due to a host of temperature-induced climate-related catastrophes. And they claim that the only hope to avoid such disaster and destruction, which they say is already underway, is for society to immediately reduce and scale back its CO2 emissions in order to achieve a policy of net zero emissions by 2050. But how accurate is this narrative? In answering this question, let us return to our previous figure and examine the historic temperature and CO2 records more critically. Certainly, these two variables experience a fairly high degree of correlation over the time period shown. However, it doesn't take a rocket scientist, or in this case, a climatologist, to recognize and understand the fact that correlation among two variables does not prove causation. Every textbook on statistics will teach you that. And they will also teach you that a hypothesis of causation among two variables can be rejected if there is no statistically significant correlation between them, or if the correlation fails to be maintained in a consistent and expected manner across time. Applying such principles to the case we are considering here, we can therefore confidently state that if carbon dioxide is indeed the all-important control knob of temperature that climate alarmists claim it to be, then changes in atmospheric CO2 should always precede changes in temperature. And because CO2 is a greenhouse gas, to prove causation, those changes must always be such that a rise in CO2 induces a corresponding rise in temperature, whereas a decline in CO2 must always induce a corresponding drop in temperature. Current observation, or consistent observations to the contrary, if present in the historical record, would therefore serve to invalidate a causation claim, as well as demonstrate that atmospheric CO2 is nothing more than a bit player among the many factors that drive climate change. So, what do the records show? Many of you may be surprised to learn that the historic temperature and atmospheric CO2 records do indeed violate the aforementioned principles of causation, and they do so more often than they maintain them. Multiple peer-reviewed scientific studies, for example, have demonstrated that following the termination of each of the past several global ice ages, air temperatures have always risen well in advance of the increase in atmospheric CO2. In fact, during these glacial terminations, which represent the most dramatic warming events experienced on Earth over the past million years, the air's CO2 content does not even begin to rise until some 400 to 3,000 years after planetary warming starts. Now, this next slide illustrates the observed temporal lag in CO2 as produced by a team of researchers examining glacial termination 3 245,000 years ago. In particular, note the temperature proxy shown in red, which has been shifted by the authors to the left so as to match the rapid rise in atmospheric CO2 that followed 800 years later. And remember, this leading rise in temperature and subsequent lag in CO2 increase, which relationship is opposite climate alarmist expectations, is a consistent and proven feature at the termination of all ice ages in Earth's recent geologic history. Another violation of the principles of causation in the CO2 temperature relationship is witnessed at the onset of ice ages. Here, scientists report that temperatures always drop first at the start of the glacial periods, and they do so well before the air's CO2 concentration begins its decline. What is more, similar to glacial terminations, these data also indicate that the CO2 decreases observed at the beginning of the ice ages lag behind the temperature decreases, often by several thousand years. Other equally problematic findings in the CO2 temperature relationship have been discovered by scientists examining periods other than the onset or termination of the most recent ice ages, including times when CO2 rises and temperatures fall, times when CO2 falls and temperatures rise, or times when a change in either of these two variables or parameters evokes no change in the other. And once again, such changes in CO2 are typically observed to follow changes in temperature from hundreds to thousands of years. A more recent example of such contrary behavior is illustrated in this graphic of atmospheric CO2 and temperature during the current Holocene, where it is seen that for 7,000 of the past 10,000 years, atmospheric CO2 concentrations rose while air temperatures declined. Now think about that. If CO2 was indeed the potent climate-controlling greenhouse gas that climate alarmists claim it to be, global temperatures would not have declined 1.3 degrees Celsius in response to the concomitant 25 part per million increase in atmospheric CO2 that occurred over this period. Rather, this rise in CO2 should have warmed planetary temperatures, but it didn't. The harsh reality is, in conjunction with all the other conflicting and contrary observations I've already shown you regarding the historical relationship between atmospheric CO2 and temperature, it leaves little doubt that forces other than CO2 play a much greater role in controlling and driving changes in global temperature. And as one final example of this fact, we will next examine the most recent 150 years of the instrumental temperature record. Over this period, it is estimated that carbon dioxide concentrations increased about 40%, and global temperatures rose between 0.8 and 1 degree Celsius. According to many climate alarmists, some 3/4 to 100% of this observed temperature rise was of anthropogenic origin, most all of which warming they ascribe to the concomitant increase in atmospheric CO2. This is because, notwithstanding the plethora of observational data that demonstrate otherwise, the only narrative climate alarmists are willing to embrace regarding the CO2 temperature relationship is one in which atmospheric CO2 is a powerful greenhouse gas whose increase will always result in climate warming. And based upon that narrative, they have constructed multiple highly sophisticated, though imperfect, computer climate models, which do not surprisingly project dangerous global warming is underway in response to the modern and still ongoing rise in the CO2 content. Well, the historic record of CO2 and temperature relationship over the past 500,000 years certainly proves problematic to this thesis. In actuality, one really need only examine the most recent 150 years to recognize there is little or no rigorous evidence that rising concentrations of CO2 are causing dangerous global warming. One red flag that immediately pops up when focusing on this time period is the observation that despite a consistent and near exponential rise in atmospheric CO2 over the past 150 years, temperatures fluctuated between periods of both global warming and global cooling. In addition, it is difficult, if not impossible, for climate alarmists to adequately reconcile the fact that the two largest warming events that occurred in this record, the first between 1910 and 1945 and the second between 1975 and 2005, experienced nearly identical rates and magnitudes of warming, despite an atmospheric CO2 increase in the latter event that was 5 times that which occurred during the former event. Nor is it easy for climate alarmists to adequately explain without abandoning their CO2-induced global warming thesis how a 3-decade-long cooling event can follow a 3.5-decade-long warming event when the CO2 increase during the cooling event was twice that which occurred during the preceding warming event. The only way to properly reconcile each of these contrary observations is for climate alarmists to admit they have overestimated the warming power of atmospheric CO2. And if you haven't yet been convinced of this fact, I offer the following additional evidence. In this slide, a record of the historic temperatures of the past 4 ice age cycles is presented. Notice that the peak warmth of the preceding 4 interglacial periods was between 1 and 2 degrees Celsius higher than that observed during the current interglacial in which we now live, despite there being 45% more CO2 in the present atmosphere. Thus, even if temperatures were to warm another 1 or 2 degrees C above their current values in the near future, there is no way such warming can definitively be attributed to the additional CO2 humans have added to the atmosphere in the modern era, because the higher temperatures in each of the past 4 interglacials occurred under CO2 concentrations that were about half the value as they are today. Another problematic issue for climate alarmists is the recent global warming pause, or temperature hiatus. Despite an 11% increase in atmospheric CO2 over the past 2 decades, which increase represents 1/4 of the total increase in CO2 during the modern era, global temperatures have shown little, if any, warming. Not surprisingly, not one of their climate models predicted this temperature plateau. Expecting warming, they all failed to see it coming. And speaking of the models, according to theory inherent in all climate models, CO2-induced global warming of the past 40 years should show a unique fingerprint in the form of a warming trend that increases with altitude in the tropical troposphere, as indicated by the red and orange colors presented in the center of this figure and outlined in blue. Changes due to solar variability and other known natural factors do not yield this pattern. However, as shown in this next slide, real-world observations do not match this model expected theory. Each of the red bars on this graphic shows warming that should have occurred in the tropical upper troposphere over the period 1979 to 2017, as predicted by simulations from 102 different climate models. The average predicted warming rate over this nearly 4-decade-long period, as shown by the black horizontal dashed line, is 0.44 degrees Celsius per decade. In contrast, radiosonde measurements obtained in this portion of the atmosphere, as shown in blue, reveal that the actual warming rate is 3 times smaller than that predicted by the models. This divergence between model projections and observational data is even more evident in this next figure, which plots both predicted and observed temperature anomalies of the upper tropical troposphere. Once again, observational data reveal that the model-derived projections of CO2-induced global warming are running far too hot. So much so, in fact, that mathematical analyses confirm a statistically significant difference between the two temperature series. Now, that key fact alone is sufficient to provide more than enough of a credible scientific basis for invalidating all of the climate models and their associated predictions. In closing, considering each of these several evidences I presented to you, it is truly disingenuous for climate alarmists to claim with any degree of certitude that the modern temperature increase bears an anthropogenic fingerprint, or that rising atmospheric CO2 is causing dangerous global warming. There exists far too much data to the contrary. And because the models all fail in this regard, the global warming debate should really end here. For pretty much all of the additional ancillary climate-related predictions made by climate alarmists rely upon the unrealistic temperature rise predicted by their invalidated climate models. And thus, we have no alternative but to conclude that indeed there is little or no rigorous evidence that rising concentrations of CO2 are causing dangerous global warming and threatening life on the planet.
Jeffrey Bennett for the negative. Have a chair.
Thank you very much for coming out tonight. I really appreciate seeing such a big crowd, and thank you to Gene and the Soho Forum and Reason Magazine for sponsoring this debate. This is the first time I've ever done a formal debate, and I know it's also Craig's first time, so we appreciate your being kind to us here. Thanks. So I take issue with most of, maybe all of what Craig said there, but there'll be time for my rebuttal later, and there will be time for the audience to ask questions later. So I want to just focus on that resolution, which says there is, quote, little or no evidence of any danger from global warming. Now, I'm going to start with a caveat. I'm an astronomer, not a climate scientist, so there's plenty of intricacies of climate science that I can't speak to with authority. However, it turns out that astronomy offers a really good way to approach this topic in terms of understanding what the actual evidence is. So I'm going to start with what I like to call a tale of two planets here. So what you see on the screen is Earth and Venus, and they are shown to scale. And you can see that they're both basically the same size. In addition to both being the same size, we know from other data that they are, in most respects, almost identical planets, except for one. You can see that the surface temperatures are enormously different. Earth has a pleasant temperature, Venus is hot enough to melt lead. And what I'd like to get you to do is think the way scientists think when they start to see something like this, which is to first ask, why would two planets that are otherwise so similar differ in this one particular way? Now, most people first guess that the answer is distance from the sun because Venus is closer to the Earth. But you can see here, this is our scale model of the solar system in Washington, D.C., outside the Air and Space Museum. If you look here at the sun, right there, and then you see where Venus and Earth are. If you imagine a giant bonfire at the sun, well, sure, Venus is going to be a little bit closer to it, but not enough to account for that enormous temperature difference. So if it's not the distance from the sun that explains the difference in these planets' temperatures, what is it? And the answer is the greenhouse effect, which Craig mentioned. This is well understood science. We get energy from the sun in the terms of visible light. The surface of a planet returns it in the form of infrared light, represented by those red arrows. And greenhouse gases, the blue dots in this picture, like water vapor, carbon dioxide, and methane, absorb and re-emit the infrared light, and thereby adding energy to the heat and surface and lower atmosphere of a planet. And this works actually just like a blanket does. If you put on a blanket on a cold night, the blanket itself doesn't give off any heat. The reason it warms you up is because it slows the escape of your own body heat. And the greenhouse effect works like a blanket for planets. And the more greenhouse gas, blue dots in this picture, the more that your planet is going to warm up. Now, if you'd never heard of this before and you're thinking like a scientist the way I asked you to, you might say, well, Jeff, that's a very nice story, but why should I believe you? And the reason you should believe me is because of the evidence. So first off, we can actually measure the greenhouse effect in the laboratory. You basically put gases in a tube, measure how they interact with different wavelengths of light. And this is not new science. It's been done since 1856. Then, once you have all those measurements, you can use them to calculate the expected temperature of a planet. And what you find is that when you look at the predicted temperature with the greenhouse effect, you get correct answers. When you look without it, you don't. In fact, for the Earth, this little equation there shows without the greenhouse effect, this planet would be completely frozen over. The only reason life exists on this planet is because we have a naturally occurring greenhouse effect. And so that brings us back to wrapping up our tale of two planets. On Earth, we have enough greenhouse gas existing in our atmosphere naturally to make our planet livable. Venus has so much carbon dioxide in its atmosphere that it creates an extreme greenhouse effect that explains that very, very high temperature. And so I like to put it this way: if the greenhouse effect is a good thing for life on Earth, Venus is absolute proof that it is possible to have too much of a good thing. And that is where scientific concern about global warming begins, because we know carbon dioxide is a greenhouse gas, and we know that its concentration is indeed rising, primarily through the burning of fossil fuels. And as you can see in this slide, since the measurements began in the late 1950s, it's gone from about 315 parts per million up to over 410 parts per million today. In fact, as Craig mentioned before, we can look at the historic geological record from ice cores from Antarctica, and we actually have an 800,000-year record of the carbon dioxide in Earth's atmosphere right now. And what you can see is that we're actually about 45% higher now than at any time in the past 800,000 years. And if you extrapolate that curve there upward and say, if we keep burning fossil fuels as we're doing today, what will happen? You find that we'll be at double the pre-industrial value, 560 parts per million, by the time today's school kids are my age, and at triple that value, approaching 1,000 parts per million by the middle of the next century. And that brings me to the summary that I like to call global warming 1, 2, 3. One, we know that carbon dioxide is a greenhouse gas that makes a planet like Earth warmer than it would be otherwise. Two, we know that the use of fossil fuels is adding more carbon dioxide to the atmosphere. And when you put those two facts together, the very obvious conclusion, three, is that global warming will happen. And in fact, this basic physics is well established. We know it through our studies of the greenhouse effect. We know it through Venus. There's really no doubt about it. And even tonight's resolution doesn't dispute this. It's just arguing about whether or not it's dangerous for us. And so to show you why I think it is dangerous for us, and I should just quickly caveat, it is not going to kill off life on Earth. It's not even going to drive us to extinction. It is dangerous for our civilization and our survival with the current prosperity that we enjoy. Here's a graph that shows you the global average temperatures going back to 1880, and you can see quite clearly that it is warming. It's warmed about 1 degree Celsius, almost 2 degrees Fahrenheit since 1880 overall. It is not a smooth curve because climate is complex. Also, some places will warm more or less than others, which is why some scientists prefer the term climate change to global warming. I usually use global warming, but either one is fine. So I'm going to show you a little video here. This is a video created by NASA. You can see the years going by at the bottom, and it's showing you regional temperatures. Blue is cooler than the 20th century average. Red is warmer. And even as you get into the mid-century, you can see things fluctuating back and forth where you don't see any clear correlation, as Craig already explained to us. But keep watching there into the 90s, 2000s, 2010s. I think you're starting to see the pattern quite clearly. And you'll notice that the world is warming all around, but in particular in the Arctic regions. Now, what effects does all this have? Why are these effects dangerous for us? Well, there's lots of different consequences that scientists have investigated, but I like to divide them into 5 main categories that I'll go through for you now. The first are the effects of this regional climate change. And here I've picked a picture, since I'm from Colorado, I live in Boulder, Colorado, a picture of wildfires that are clearly increasing in magnitude around the world. But there's many other effects. There's more hotter days than there used to be. The data show that clearly. Nights are warmer than they used to be. Data show that clearly. The range of weeds and pests is increasing. Data show that clearly. There are more droughts, more floods. Data show all those things clearly. Secondly, The second major consequence is the increase in storms and extreme weather that you've probably noticed as you watch the weather reports or experience the weather for yourself. And I want to point out, this is not mysterious. Remember what global warming's doing. It's adding more heat and energy to the atmosphere and oceans, and heat and energy are the drivers of weather. And in fact, for those of you who like numbers, the numbers are quite astonishing. The greenhouse gases we're releasing have created a global energy imbalance in which Earth's atmosphere and oceans are gaining approximately 250 trillion joules of energy per second, which is the equivalent energy that will be added by detonating 4 Hiroshima-size atomic bombs every second. That's measured in a couple of independent ways. And when you think about that much energy, 4 Hiroshima bombs per second, added to the climate system, and you know energy drives heat and weather, it's not a surprise that we're seeing more extreme weather events, a trend that will only worsen in the future. The third major consequence is the melting of sea ice because the Arctic is warming so much more, and that has many other detrimental effects. For example, because ice reflects a lot of sunlight and water absorbs it, the decline in ice coverage actually amplifies other effects of global warming. The melting of sea ice also changes the salinity of ocean water, and some studies have even tied the reduced ice to changes in what's been called the polar vortex, which may be the cause of some of the extreme winter events that we've experienced here in the US in recent years. The fourth major consequence is rising sea level as seawater expands through heating and landlocked ice melts into the oceans. Scientists still have a lot to learn about how rapidly ice will melt, but it's a near certainty just from thermal expansion of the seawater alone that sea level will rise by at least another 1 to 3 feet before the end of this century, and possibly much more, which will not only flood many coastal regions, but as New Yorkers will remember with Hurricane Sandy, a storm surge can greatly magnify even a relatively small sea level rise. The fifth major consequence is ocean acidification, and that occurs because only about half the carbon dioxide we are emitting into the atmosphere is staying there. The rest is being absorbed, some by plants, some by the soil and the oceans, and in the oceans, the carbon dioxide dissolves and makes the ocean water more acidic. The combination of this acidification and the warming ocean temperatures has been linked to coral reef bleaching, declines in ocean fish stocks, and many other effects which harm our ability to harvest food from the oceans. There's one more general science point I'd like to address, and that's to put today's changes in geological context. This is the same 800,000-year ice core record that I showed you before, but now showing global average temperatures on the top as well, and we can talk during the audience Q&A about the correlation that's there that Craig disputes, but it's real. As you can see, Earth's climate changes naturally and substantially. The bottoms represent ice ages, and the peaks represent the warmer interglacial periods. So one of the common questions is, if the climate changes naturally like that, why should we worry now? And the reason is because today's carbon dioxide concentration is rising far beyond what it has done naturally in the past 800,000 years. And we actually expect there to be a lag time of a few decades between when the carbon dioxide rises and when the temperature rises, and that is why most scientists are very concerned that we will soon see that temperature curve rising similarly to the way we see that carbon dioxide curve rising. In fact, the only way you would not be worried about that would be if you thought there might be some reason that the temperature won't respond to this carbon dioxide change, which is essentially what Craig was arguing. And that gets to an issue called the climate sensitivity. This is what Craig and many of the other so-called skeptics often argue. In essence, they're claiming that there's some mitigating feedback that will limit the temperature changes. But no such feedback is known, and there's every reason to believe that the climate really is that sensitive, and not only from the models, because as Craig and other skeptics often point out, if you look back millions of years, there were times when life on Earth thrived when the carbon dioxide concentration was much higher than it is today, 1,000 parts per million or more. But Earth was also so warm at those times that there were no ice caps at all. And that means that this fact actually supports the conclusion that temperatures could, in principle, go much higher than they are today. And from our understanding of Earth and Venus, we can be very concerned that they are. So I want to summarize. I've shown you the overwhelming evidence that makes the 1, 2, 3 case established by 160 years of physics that greenhouse gases like carbon dioxide really do make planets warmer. I've shown you why we expect 5 major categories of consequence. I've talked a little bit about the fact that this is all supported by evidence. Well, what evidence? More than 50,000 peer-reviewed papers published on original climate research in the past 2 decades alone, and more than 99.9% of those consistent with the consensus view that global warming poses a threat to civilization. The only way you could possibly agree with tonight's resolution that there is, quote, little or no evidence is if you believe all this evidence has somehow been faked, that somehow the many thousands of scientists who studied this, the people and organizations and students who support their work, are all part of a great conspiracy to deceive you. Unless you believe that, this resolution is not a matter of opinion. There is strong and abundant evidence of danger. Whether you agree that it is really dangerous, that's opinion, but the fact that there is evidence is undeniable. And just in case you think maybe it is all a conspiracy and that there is little or no evidence, I'm going to close with the words of a noted chemist who also happened to be the first major global leader to speak out on this topic before the United Nations. This is what she said in 1989. What we are now doing to the world by adding greenhouse gases to the air at an unprecedented rate is new in the experience of Earth. It is mankind and his activities which are changing the environment of our planet in damaging and dangerous ways. That was Margaret Thatcher, and you'll notice that she understood both the science and the threat. So unless you think she was part of some vast conspiracy too, then it should be clear that tonight's resolution demands a resounding no.
Rebuttal from Craig. Yeah. Okay.
All right. Can you hear me? So nothing in Dr. Bennett's presentation is sufficient to negate or overturn the facts I presented to you previously. Although atmospheric CO2 is a greenhouse gas, it is not the control knob that drives global temperature, and it is certainly not causing global warming. The historic record is clear. A control knob does not consistently lag several hundred to thousands of years behind changes in the parameter it is supposedly governing. And a control knob most certainly does not proceed and produce multiple occurrences of a response that is opposite its expectation. Climate alarmists want you to ignore such contrary empirical behaviors, even though they are far more characteristic of the historic relationship observed between atmospheric CO2 and temperature than they are not. I would also remind you that the fingerprint of CO2-induced global warming, the predicted temperature rise of the upper tropical troposphere, which is supposed to provide the definitive proof validating the climate model projections, has failed to show itself in the observational data. This fact alone, if you accept the scientific method, should be more than sufficient to convince you that dangerous global warming is not occurring or that it ever will. Consequently, all the ancillary climate-related catastrophes that require a dangerous temperature rise to ensue are also unlikely to occur. And if we had enough time in this presentation period, I would present you with a full data-driven rebuttal showing a lack of confidence in the claims that Dr. Bennett brought up. But alas, we don't have that time, so I'll leave it up to you to bring and ask me those questions that concern you the most during the Q&A period, and I will share with you some equally damning data, and then that further demonstrate that the planet is not in danger of imminent peril because of increasing CO2. And in fact, the reality is pretty much the opposite. Rising concentrations of atmospheric CO2 are actually benefiting humanity and the biosphere in a great number of ways. Now, to give you just a taste of such benefits, I'm going to end by sharing with you the results of a recent scientific study examining the health and vitality of the terrestrial biosphere over the past 34 years. Now, employing a series of globally distributed data sets, the authors of this study examined changes in planetary gross primary productivity over the period 1982 to 2015. But before I advance to the next frame, however, I want you to consider that since 1980, the Earth has weathered 3 of the warmest decades of the modern instrumental temperature record, as well as a handful of intense and persistent El Nino events, large-scale deforestation, as well as supposedly unprecedented forest fires, and episodes of persistent and widespread severe weather events, including droughts, hurricanes, and floods. At the same time, the Earth's CO2 concentration has increased by more than 16%, and the human population has grown by over 55%. To global warming alarmists, the Earth has been in the throes of a veritable climate Armageddon. So just how bad has the planet suffered in response to these supposedly much-feared events? Well, the answer, frankly, hardly at all. Despite the many real and imagined assaults on vegetation and humanity and nature alike, including the perceived dangerous CO2-induced global warming, the terrestrial biosphere has met and overcome these challenges, if they even were challenges. As indicated in this graphic, the spatial distribution of the linear trends in gross primary productivity over the past 34 years are overwhelmingly positive, revealing a persistent and widespread vegetative enhancement which occurred on over 75% of the planet's land area. And as icing on this cake of good findings, the researchers who conducted this analysis determined that the principal factor responsible for inducing these positive trends just so happens to be the same factor climate alarmists claim should be obliterating them. Yep, you guessed it, rising concentrations of atmospheric CO2. Just like you learned in 5th grade science class, CO2 is plant food, and the more CO2 we put in the air, the better plants grow. How ironic this is, even more so when one learns that the next most significant factor contributing to this planetary-wide growth stimulation was rising temperatures, albeit its influence was more than 5 times less than the positive influence exerted by CO2. It would thus seem that climate alarmists have missed nature's memo. Recent warming has not been dangerous, and rising atmospheric CO2 is benefiting the biosphere.
Thank you. Okay, Ruben.
Thank you very much. So actually, I'm going to start with that last point. It is true that the Earth has been greening, as Craig just showed us. But you might be wondering, how do we know that it's caused by carbon dioxide rather than changing in agricultural processes and so on? What Craig didn't tell you was that the way we know it's caused by carbon dioxide, and it is through models. But remember earlier, he told you he doesn't trust models. So which is it? In this case, he's correct, and the models are correct. More important, he claims that this greening is obviously beneficial, but that doesn't make any sense. If I told you that you've been gaining a lot more cells in your brain, it might mean that you're learning a lot more, but it could also mean you've got brain cancer. And in fact, it doesn't take much digging into the research to learn that the research that Craig claims is supporting benefits actually is more in line with cancer. For example, Craig's the lead author of this thing called the NIPCC, the basically non-governmental IPCC that claims to refute the IPCC report, sends out hundreds of thousands of copies to teachers around the world trying to confuse them. And here's their summary for policymakers.
Check one.
If it comes up.
Check.
That's don't count my time on this. That's not. Those are not my slides. Okay, there we go. So this is from the summary. Here's summary of the from their report, and it says the result, what he was talking about, is a remarkable and beneficial greening of the Earth, and he cites 3 references. But I went and looked up those references. The first one actually came with a press release saying that the limited benefits do not outweigh great dangers. The second one, they were so upset at being cited here that they wrote a rebuttal in which they said they referenced our scientific study but distorted the facts. And the third study he cites in the abstract, which is the summary that the authors put at the beginning of the paper, they actually said some vegetarians vegetation would benefit, however, most would suffer and experience irreversible change. This is not an isolated example. The research that he claims is saying one thing is saying the other, and you could check for yourself easily. I looked at his website and looked up the various things he talks about. His homepage has 2 videos up at the top. The first video talks about all the great things that are going to happen with carbon dioxide in the green of the earth. It cites 2 studies. One is, again, just like the other examples I showed you, clearly taken out of the context. The second study it cites is his own paper on economic benefits, but nowhere in the video does he tell you that it's his own self-citation, which scientifically is not really considered a legitimate practice. The second video shows 2 plants growing under different carbon dioxide concentrations, with the one with the higher concentration growing faster. Well, that's not a surprise. Of course, if you give 2 organisms the same living conditions, but one of them you give more nutrients, it's going to grow better. But in the real world, we have to ask questions like, how will our crops do when they are battered by more extreme weather and drought? What about the fact that the weeds are also going to grow faster, and that pests will move into new territories as the climate changes? The fact that he even posts a video like that suggests he thinks you're pretty easy to fool. His website also lists numerous other studies that supposedly support his claims, as well as a list of scientists whose research they cite supposedly in support of his claims. I went and read a set of those studies, and I emailed a sample of those scientists, and guess what? None of the studies I read actually said what he says they claim, and every single scientist who responded to my email said they were being taken out of context. Sample quotes included, "This is madness, what a travesty, and where do these weasels come from?" And the IPCC represents just a body that synthesizes the work of thousands of other scientists around the world. Everything they do is transparent, explained on their website. These are thousands of researchers devoting their lives to real science, working very, very hard. Craig thinks they're all too stupid to understand simple little things like correlation and causation. Of course they understand these things, and they investigate them, and they spend years doing it. Who does the work that Craig's citing, this NIPCC he represents? Well, it has a list of contributors, so I looked them up. It turned out of the about 100 or so people contributing to it, only 15 of them did I find who've ever engaged in anything that might conceivably be considered original research in climate, and none of them are still active researchers today. I don't do original climate research either, so in that sense, I'm kind of like you are. You're hearing one thing, you're hearing another thing. Who do you trust? Well, you could do what I did. Look up some of these things for yourself, and you'll find that he is presenting a distorted picture of what the scientific community is actually doing. And you can walk over to any university or research center, walk in, talk to the scientists about how they do their work and what they're doing, and you'll learn that they're working hard, diligently, and to the best of their ability to understand this topic clearly.
Thank you for your spirited debate. We get to the Q&A portion of the evening. I'm going to begin by exercising debaters, moderators rather, prerogative to ask my questions, but you may want to line up. But first I want to ask either of you would, at this moment, you'll have options to do this throughout the next period of Q&A. Do either of you want to ask the other a question at this moment? No? Pass on that? Yeah, we can do that. Do you want to ask the other question?
I do.
Oh, Jeff, go ahead. Yeah.
So, Craig, suppose that someone were to invent a technology that we could attach to our cars and our power plants that would capture all the carbon dioxide emissions before they get into the air, and it could be installed with essentially no cost. So we could just keep living exactly as we are, but no more greenhouse gas going into the air. Are you for or against this?
Let me find the right slide to show you, to share why. Let's go to slide number. Let's go to slide, actually, sorry. Let's go to slide 84, please. You know, there are consequences actually for stopping all CO2 emissions. A lot of times they think that this is an insurance policy that that there's no reason not to emit CO2. But in fact, there are consequences if we stop the CO2 from rising. And part of that is explained here in this graphic, which shows you an amalgamation of several studies. This is back in 1992. Now, there's actually literally been thousands of peer-reviewed scientific studies that examine the effects of CO2 on plants, okay? And so there's not just 2 or 3 on my website. You can go there and you'll find more than 5,000 experimental results. And what these studies all show is that as you increase the CO2 concentration of the atmosphere, plants experience an enhanced growth. Now that'll translate into many benefits, including agriculture, all right? So as a population of the planet continues to grow, how are we going to feed the planet? Well, this is one way that we can do that. CO2 helps provide this benefit of increasing our agricultural output. So there you have a negative thing. If we took away the CO2, we would not be allowing ourselves to have this benefit. And there's a number of researchers that say that by 2050, the Earth could be food insecure because of the rising population of the planet. And so that's one negative, absolutely, that would come, is the reduction in agricultural output.
So you would be against using this technology that would, with no cost, stop our CO2 emissions and let us keep living otherwise as we are. So just to make sure I'm clear on that, I've seen your quotes saying that no one knows the optimal CO2 level for Earth, but you're willing to run the experiment even though you've got tens of thousands of scientists who say this is dangerous. Even if we could do it for free and stop it, you would just keep running the experiment to see what happens to us.
If you look at this graphic here, you can see the benefits of CO2 go out beyond up to 2,000 parts per million.
So again, you got tens of
now,
thousands of scientists.
We're never gonna get to 2,000 parts per million.
Why not?
So these benefits, because most of the estimates today suggest that we'll never get there even if we burned all the fossil fuel reserves that are available.
But going higher
right
at
now.
all. So you just think we should keep going higher even if we could stop it for free.
There's absolutely positive benefits that are gonna come from it. It's not a danger to the planet.
Do you have a question? Do you have a question for Jeff?
Yes, I do.
Yeah, okay.
And to preface that question, I would like to show a figure. So let's go to figure number 60, please. So this is a graphic here. You know, you brought up, Jeff, that extreme weather events are increasing. Well, how come we see data like this, where tropical cyclone frequency, this is global hurricane data from 1971 to 2018, and it's looking at the frequency of hurricane and tropical storms. And we look at this graphic and we don't see an increase. Okay, so they're not increasing. We could go to the next slide as well. Intensity. This is a measure of intensity, global hurricane energy, accumulated energy. We see, again, no trend upward. Again, if CO2 was the controlling factor of these extreme weather events, why do we not see that occurring here?
It's always possible to cherry pick the data.
This isn't cherry picking.
What you have.
This is global data.
So again, we've got thousands of scientists who've looked at all kinds of data, come to the conclusion that extreme weather events are increasing.
So you're disagreeing with this data here?
I'm disagreeing that this is representative of extreme events overall. It's like you're picking one particular topic. Extreme events overall, insurance companies are noticing this. In fact, they actually keep some of the best data in my global warming primer, which you can read for free online, because I have the whole thing posted there. You can see the data collected by Munich RE, which shows the increasing number of extreme weather events going on. But even if we weren't seeing the signal yet, and we are, we know from the basic physics of global warming that as we keep doing this, it's going to happen. The idea that more greenhouse gas will make a planet get warmer is as clear as the idea that dropping a ball off a building, it's going to fall down.
So if I showed you data from additional studies that showed different extreme weather events did not occur, would you like to see those data or would you not want to see them?
You can show me anything you want. I'm not a climate scientist. I am an astronomer who's looking at what the experts are saying. And again,
So do you want me to show you the data or not?
you can show me
Okay,
anything
let's go to
you
the next
want.
slide then, please. I have about 4 slides to show.
Okay. Well, make it just one, please. Make it one.
Yeah, we do want to get to audience
Yeah,
questions.
wait.
Okay, let's go to 70 then. This is one that you brought up.
What?
You number 70.
70 got it? Okay, that's the last one.
Okay, this is a study that came out in 2014. Okay, and it's looking at decadal variation of global burned area. This is the best science that's been done to sum global data. Now, my colleague here can pull out and cherry pick the data and show you a particular study where a fire had increased. But this is an amalgamation of all of those data over the globe, and what you see here is what? A downward trend in the globally burned area. All right? So that refutes this. How do you explain that? This is the data. You're going to refute the data?
So this particular graph I haven't seen, but there was a similar thing.
Okay, well, there's a lot more you haven't seen, too. I'd be happy to show you.
Some of you may have heard of, wrote a similar op-ed talking about this in the Wall Street Journal a few years ago. And he cited a study from PNAS. And just like I did with your papers, I actually contacted the authors of that study because I was confused. I said, it looks like the wildfires are going down. And they said, you need to read our paper more carefully. It's being completely misinterpreted in that Wall Street Journal column. I can't tell you exactly what you're misinterpreting here. All I can tell you is, again, thousands and
that's
thousands
being misinterpreted, isn't it? Yep, a downward trend.
You've picked
It's really
one,
going up.
You said I can't pick one slide, but you did pick one slide. Thousands of scientists are telling me that the wildfires are indeed increasing.
All you have to do is look behind you. You don't have to listen to the thousands.
I have a quick question to put to each of you, moderator's prerogative, and then we'll leave it to questions for the audience. First question to you, Craig. What you keep saying that carbon dioxide doesn't seem to be causally related. You don't get the correlation in causal terms. What else could be affecting the temperature change? What else could it be?
Absolutely natural. Let's go to slide 64. This isn't a temperature, but it'll help explain that. So what you see here, this is natural variation in sea ice cover, okay, over the last 10,000 years. I showed you the slide of temperature over the last 10,000 years. This is sea ice variation. As you can see, natural variability is huge over these longer timescales, and even on some shorter timescales as well. Now, we are presently in the far left portion of this graphic, okay? And you can see that the variations that we see right now over the time period of our lives is minuscule in comparison to what can occur over much longer timescales. So nature has a way on its own via natural factors that drive most of this. Now, what is it? It's probably solar related, changes with the sun. It could be the ocean, internal oscillations, and so forth. The fact is, we just don't know, and I'm willing to admit that. It's clear CO2 is not the control knob of climate.
You have a comment, Jeff, before I get to your question?
Yes, sure. CO2 is the control knob of climate.
Okay.
That's well established by the greenhouse effect. And I do want to point out again, I haven't seen this particular graph either. What I do know is every study I read that Craig claimed was supporting his point of view, when I actually read the study, it wasn't. You could check that for yourself too. You can pick slides out of context any way you want. It doesn't change the of more than 50,000 peer-reviewed papers, 99.9% of them supporting the dangers of global warming.
Just to comment on that, actually that is false. There's a number of studies that don't show this to be problematic. And I also invite you to look at the data for yourselves. It's not hard to understand that those who receive billions of dollars in funding for this issue are going to circle the wagons and say, yes, it's a problem and we need to keep studying it.
Yeah, a quick question for you, Jeff. The problem that some of us have who read the New York Times, for example, is that I came across in 1989, I read a prediction that Manhattan would be underwater by the year 2000. I saw Inconvenient Truth, and it was about 2 years ago that Manhattan would have been underwater. We're now in the basement, we're still not underwater. And so all of these all of these thousands of peer-reviewed scientists keep telling us things that never come true. So we idiots are beginning to get skeptical of what all those peer-reviewed people are doing with themselves. So could you address that?
Sure.
Yeah.
So you probably also remember that in the 1970s they claimed that the globe was going to cool and so on.
Exactly, yeah.
It's not true. If you actually look at the studies back then, I was in college studying studying some of this at the time. The papers that were being published were saying warming will be coming. Time magazine ran a story about cooling. Time magazine is not a scientist. Al Gore is not a scientist. The New York Times writers are not scientists. What the scientists are saying, and if you look back at what James Hansen predicted about the temperature in 1988, the actual warming that's occurred since then is right in the middle of the range that he predicted. If you look at the actual scientific papers that were coming out at that time, everything that we are seeing today is actually quite well in line with that. In fact, the famous Swedish chemist Arrhenius, back in 1900, did a back-of-the-envelope calculation based on the physics of the greenhouse effect of what would happen with a certain rise in CO2, and his back-of-the-envelope calculation turns out to be quite close to what the most complex computer models are showing today. I can't help the media overblowing things sometimes, but that doesn't change the fact that the clear scientific case and evidence has been building for 160 years now.
You are saying, contrary, I read something, there was a quote from a press release, 1989, in the year 2000, Manhattan would be underwater from a climate scientist from the UN. And you're saying James Hansen and all the rest of them, their forecasts have actually been on the money. Is that right?
They've been, there's always predicted uncertainty ranges, and they have been right pretty close to the center of their uncertainty ranges.
Can I address that, please? Slide 73.
Yeah.
Okay. Let's see how well those predictions are going, okay? This is a recent study that came out last year in the Journal of Marine Science and Engineering. There's the reference. Please go look it up. You'll see I'm not distorting the truth. What you look at here is these are model projections of sea level rise from the period 2007 to 2016 compared against observations. And it has error bars here as well. The dark lines, the dark horizontal lines, are the tide gauge trends and what's actually occurring in the data. The light blue line is the projections made under 3 different scenarios of the climate models. And what you find, as I have highlighted here in yellow, over the past decade, the ensemble model mean projections of future sea level rise are approximately twice the magnitude of that which is observed in the tide gauges. The models are failing.
And as I told you during my presentation, sea level rise, ice melting is the thing that we have the most difficult time understanding right now. We know there's a problem with the models for sea level rise.
That's right. They overestimate it all.
Okay, thank you. And Q&A, please state your question as a question, and you have to go up to the mic for a question, sir. Sorry, got to get on. Question, please. Go ahead. Yes.
My question is for Jeff. So I assume that you're in favor of banning fossil fuels at some point?
I'm in favor of replacing our current energy sources with ones that don't release CO2 into the atmosphere, but only, right. So I'm not in favor of us just getting rid of something without having something.
Are you in favor of nuclear power?
I am.
Oh, okay.
Absolutely. I should just on that topic, I'll point out people worry about the dangers of nuclear waste, and nuclear waste is a real problem. In an hour, a coal plant produces more toxic waste than a nuclear plant produces in a year. And the nuclear power plant's waste will be, in principle, dangerous for thousands of years. The coal plant's waste is dangerous permanently. It doesn't even have a half-life. It's dangerous forever. So yes, I'm in favor of nuclear power.
Comment? Go on.
Yeah, I'm in favor of whatever energy is the cheapest that we can get to help raise humanity out of energy poverty.
Next question.
As long as it's fairly clean.
Next question.
Why is it that for certain graphs, you've included error bars, but certain graphs you have not. Specifically, the time lag graphs for the ice cores. Right? How precise are the time measurements for the temperature, the corresponding CO2 measurements there?
That you'd have to go back and look at the individual papers. Those graphics come
Could
from...
it be larger than 800 or 400 years?
No, I don't believe so.
Based on what?
What the authors published. That they all came out and say, I gave you those several references that they all come out and they show you.
But that could show a trend, right? Even if it didn't have that level of precision.
Give him the mic back. Okay, yeah.
Gene, you want him to have it?
Give him the mic back, please. Yeah, okay, yeah. Well, go ahead.
Yeah,
say
but that could show a trend even over a long period of time, even though these specific 400 to 800 year intervals may not have that level of precision that you account for in the lag.
And that's a possibility. But again, when you see this over and over and over again, that the temperature
But those error bars
lags
should be
behind
known, right?
Yes.
Okay, yeah, sure, of course.
Let me speak to this very
Okay.
briefly.
Yeah.
So again, the idea that the temperature leads to CO2 in some of these cases is well known. It's not a surprise. We understand perfectly why that occurs, something to do called the Milankovitch cycles. You can read about it on my online global warming primer. Craig's making the assumption that when the scientists see this, they don't understand correlation versus causality, that these tens of thousands of scientists who spent their lives devoted to study of this, who've gotten PhDs, don't understand a simple idea of statistics. Of course they understand this, and they've studied it in depth. They go around the world to Antarctica, to Greenland, to isolated islands. They risk their lives oftentimes collecting the data that it takes to try to understand what's going on here. And we do understand it today. And I don't have time to get into it because I want to have other questions, but again, you can go to my global warming primer and see what the explanation for that fact is. And it's not that the scientists are too stupid to understand correlation and causation.
Okay,
And of course, I don't claim that. Obviously, scientists are very smart. But they're overestimating the influence of CO2 on climate. And that is a very debatable point.
Yeah, next question. Yeah.
One of the major scandals was that years ago, the scientists who believed in global warming rejected papers they didn't agree with and were all heavily invested in the companies. In science, I'm a retired physician. Anything you publish in medicine, you have to reveal every stock you own and all the relationships you have. And if you read the papers, several very fine people had to leave Memorial Sloan Kettering because they'd gotten shares from the companies that were doing research on. Please comment on that and the fact that in science you say it's a closed issue. You never say it's a closed issue. 35 years ago, people were doing radical mastectomies on breast cancer. The data showed that a lumpectomy was just as good. People were doing major surgery on peptic ulcers. Today, you take antibiotics a few days. So the first point I'd like you to address is the question of investments and not revealing what you have and rejections of papers that disagree with you. And the second is, how can you say anyone who knows anything about science, like John Kerry, that it's a closed issue?
I believe the question is addressed to you, Jeff.
Okay. I'll start with your second part. I don't know any scientists who say it's a closed issue. If it was, we wouldn't still be doing research on it. We have enough understanding to know that we face a substantial and real risk, that there are dangers being posed. We can't say exactly what's going to happen. That's why it requires continued study. To your first point, I don't know what companies people for the past 160 years have been investing in that's biased them in this way. I doubt if that was the case. Certainly even if you're talking about government funding, until the 1980s, scientists were doing work on this topic and they weren't getting government funding because the government funding wasn't there. As the government responds in terms of where the research dollars go to where the research needs are. And as people saw that there was a need for more research in these areas, the government provided more money for that. I can guarantee you, none of these scientists tens of thousands of scientists are getting rich. They are living on academic research salaries. They're not anything like the salaries that most of people here in New York are seeing. They're not getting rich off this. They do not have these conflicts of interest. As far as peer review sometimes makes mistakes, no doubt about that. But you have to have some system for evaluating your papers and moving forward. If you are working on a home remodel project, you got to get a certain number of bids, and you're going to get those bids from remodel contractors, not from random people. You've got, again, tens of thousands of scientists who've been studying this and coming to the same conclusion. You got Craig and a few other people at the NIPC, none of them active in research, who are saying something different.
So in actuality, there's a lot more scientists that are against this issue that would support the action, be affirmative on a resolution tonight. And unfortunately, a lot of them just don't speak out, or they wait till they're retired before they can speak out because they feel threatened. But that being aside, you know, science progresses on the scientific method, right? It doesn't progress on how many people agree with you or how many people you think agree with you. It progresses on empirical analysis of a hypothesis. That's what the scientific method is. That's what we've gotten away from in today's postmodern society. It's all about, you know, so many people agree and so forth, but it's not how science works. You know, Albert Einstein said, you know, it only takes one scientist to prove him wrong. You know, it doesn't take 100 or 1,000. It just takes one that can prove him wrong.
Next question, please.
Okay, thank you both for coming tonight. Seeing how scientists can predict CO2 levels in the future, are scientists able to see what, or rather predict, post-dict, what the CO2 levels would have been if there was no industrial revolution and if we, as humans, never started burning coal?
What you check the first question is like, Jeff. Why don't you go first?
Sure.
Craig. Yeah.
So if we had not started the Industrial Revolution, for all practical purposes, the CO2 concentration would likely have remained around 270 to 280 parts per million. And I say that because that's the concentration that it reached during all of those previous interglacial periods that we both showed graphs of. So that's about where it would have stayed. It would have oscillated between anywhere from 180 parts per million at the depths of the ice ages to about 270, 280 parts per million during the interglacial. So it's about 100 part per million oscillation that we see.
We agree.
I see, yeah. Next question, please.
Yes, thank you. Venus. When I first saw references to Venus and how Venus proves the greenhouse theory, because its atmosphere is mostly carbon dioxide, I thought, well, that seems like a good point. I'd better go look into that, and I looked into it. And the counterpoint is, the atmosphere of Venus is like 100 times more dense than the atmosphere of the Earth, and that density 100% explains the higher temperature without even getting to the greenhouse theory. And if either of the two of you have comments on that, I'd be interested.
Sure, density alone doesn't do it. Earth's atmosphere is mostly nitrogen and oxygen, and they have no effect on our planet's temperature at all because they're not greenhouse gases. They don't absorb the infrared radiation. Carbon dioxide, when it's dense, does have the effect because it's a greenhouse gas that absorbs the infrared.
Question, comment? No?
Yeah, just comment I'll make, you know, and that's a nice parallel or use that he's using there. But one thing you have to consider too is there is a difference between us beyond that, and that is Earth is a living planet, right? There's other forces that act here that don't act there. For example, you can have here's a feedback that'll happen with extra CO2 by itself. It increases the photosynthesis of phytoplankton in the ocean. As you raise the CO2 concentration, those phytoplankton emit a substance called DMS, which is a precursor to act as cloud condensation nuclei. And as the CO2 concentration goes up, more DMS gets produced that can then act as a negative feedback to incoming solar radiation. So there's a lot of other factors that don't make that a one-to-one correlation.
Next question.
This question's for the both of you. I've noticed that you have modestly different measurements for parts per million of carbon dioxide in the atmosphere, but you do have extremely different scaling. And I've noticed that does change how we're able to perceive those differences, and your timelines are extremely different. I was wondering if you could speak to the methodologies behind getting those measurements and your sources for those measurements.
Jeff?
I'm not quite sure what you're referring to. I thought our units and our timelines are basically in agreement.
Yeah, they basically are.
From the slides that we had seen, at least from back here, we noticed that one of you had 280 parts per million for the modern era, and one of you had about 400.
280 was the concentration in the year 1750, dawn of the Industrial Revolution. 315 is where it was in the late 50s when the measurement started at Mauna Loa, and 410 is where it is today.
Can I jump in and ask a question? Because moderator's prerogative. I'm curious about one point you made, Jeff, when you talked about correlation and timing. I mean, I'm in economics, and I do think that if something is happening and then the thing it's supposed to be causing happens
Sure.
before it does, then that's simply
So
not
the-
causally related. How did the scientists work that one out?
So I'll give you the brief explanation. So
Yeah.
according to our basic understanding of the cycles of ice ages that the Earth goes through, the triggering mechanism is small changes in Earth's axis tilt and the obliquity, the ellipticity of Earth's orbit. And those changes, there's 3 major cycles, and when you put them all together, they're called the Milankovitch cycles, and they actually reproduce the pattern of ice ages quite well. So the idea is that for example, when an ice age begins, these natural changes in orbit and rotation axis are causing a little less sunlight to fall on the Earth, which cools the Earth. Now that cooling, the amount of cooling by itself is not enough to explain this huge drop into the ice ages. What it does is it initiates a feedback process. So the Earth cools a little bit due to less sunlight coming in. That slightly cooler temperature means the oceans can absorb more carbon dioxide and a little bit more ice freezes. The freezing ice reflects more sunlight. By absorbing carbon dioxide out of the atmosphere, that reduces the greenhouse effect, and that further drives us to colder temperatures, which brings even more carbon dioxide out of the atmosphere, adds even more ice, which keeps driving the temperature down until we're plummeted in that ice age. And then on the return, it's the same thing. So we actually expect that the temperature should be leading because it's being caused at the trigger is that change in the amount of sunlight reaching Earth.
That doesn't imply that there are lots of other factors that affect temperature other than carbon dioxide, no?
There are lots of other factors, but that is the driver because that is the one. The greenhouse effect, so another common question is the greenhouse effect on Earth, there's actually more greenhouse effect due to water vapor than due to carbon dioxide by several times. However, water vapor, when the temperature around changes, it increases or condenses or evaporates very rapidly in response to what's going on with the temperature around it. Carbon dioxide doesn't respond quickly, and therefore it's the driver of what happens. The water vapor just responds and amplifies what the carbon dioxide is doing.
A comment, and unfortunately we don't have time for you. Comment on that.
Well, again, I mean, I think that kind of what you said is really kind of just disproves what you're saying. You know, carbon. If that's the case, if the Milankovitch cycles, and then if the water vapor are driving this, then CO2 certainly is not the most.
No,
important
CO2
driver.
is the driver that the Milankovitch cycles trigger, and it's the changes in CO2 due to those temperature changes that then have an amplifying process with the water vapor.
If that was the case, the sensitivity, the change in CO2, that 100 parts per million that we saw, we would expect to see a lot greater change or even less of a change now with the change in CO2.
I think
Anyway.
we expect to see exactly what we're seeing.
Is Milankovitch still alive?
No, he's
Long
the 1800s.
Okay. Anyway, we unfortunately don't have any time for more questions. But one more question. I heard a lot of.
Keep them coming. Craig and I just have to fly home.
I took too
we're
much
fine.
moderator's prerogative. Go ahead. Yes.
One big concern about carbon dioxide is that as you get more, it acidifies the ocean and retards carbonation or carbonification and kills sea life. But as you pointed out, over most of the last 550 million years, carbon dioxide has been over 1,000 ppm, as much as 3,000 ppm, according to Dana Royer. And so if so, it's only in the last 10 million years or so that we've had these very low CO2 eras during the ice ages and the Permian. If so, where does all the limestone come from? If limestone can't form at these high levels of CO2, if it's dangerous, why do we have limestone all over the place?
The answer is because Earth actually has, remember I showed you that slide that shows Venus has 200,000 times as much carbon dioxide in its atmosphere as Earth does. Earth actually has that same 200,000 times as much carbon dioxide, but it is all in limestone because it dissolved in the oceans billions of years ago. So the limestone comes from all that carbon dioxide dissolved over billions of years. Changes by a few thousand parts per million are small in comparison.
I'm afraid that we'll have to wrap it up at that. Thank you for your question. We'll go to the summations. Craig, please come to the podium.
So in closing, I would like to thank the Soho Forum for sponsoring this event, Dr. Bennett for being a cordial debate adversary, and for each of you for attending here this evening. The underlying question in the climate change debate is whether or not atmospheric CO2 is a powerful greenhouse gas capable of causing dangerous global warming that will threaten our planet. In testing this hypothesis, I have provided you with multiple evidences based on real-world observations that it is not. More often than climate alarmists are willing to admit, the historical record defines CO2 as the dependent variable following changes in temperature with a lag time that varies from hundreds to thousands of years. How can a cause perceived to be so powerful so often trail its supposed effect? And how can a cause elicit responses that are directly opposite its hypothesized effect? The answer is quite simple, and it doesn't take a climatologist to figure it out. It is because atmospheric CO2 is not the all-important greenhouse gas that climate alarmists claim it to be. Sufficient proof is documented in the historic records. Sufficient proof is also found in the missing fingerprint of CO2-induced global warming of the tropical upper troposphere that observations fail to capture. And sufficient proof is noted in a vast array of real-world data that fail to match model projections for a host of these subordinate temperature-related climate catastrophes. Consequently, there is little to no rigorous evidence that rising concentrations of carbon dioxide are causing dangerous global warming. Now, using another common sense approach to recognize this fact, let us return to this figure, which, if you recall, shows that all four of the preceding interglacial periods in Earth's temperature history reached values which were 1 to 2 degrees Celsius warmer than the present. And they did so naturally, despite 45% less CO2 in the air than there is now. I doubt you would find anyone on the planet, except maybe your local New York representative, Alexandria Ocasio-Cortez, who would take the extreme position that temperatures during those interglacials were dangerous. Yet recall from the comments I made at the beginning of this debate that the Paris Climate Treaty actually defines dangerous warming as temperatures that cross a threshold of 1.5 degrees Celsius above pre-industrial values. Well, as you all know, global temperatures have already warmed between 0.8 and 1 degrees Celsius since pre-industrial times. Therefore, using the Paris Climate Treaty standard, which is echoed by climate alarmists elsewhere, the planet cannot warm another 0.5 to 3/4 of a degree Celsius, or climate Armageddon will ensue. Seriously, come on, give us a break. Such warming, if it occurs, would still place planetary temperatures some 0.3 to 1.3 degrees Celsius below the warmth of the temperatures experienced during most of the previous 4 interglacial periods, which by no means were periods of planetary disaster. Clearly, the model-based projections of the consequences of rising atmospheric CO2 are way off the mark. Dangerous CO2-induced global warming is not presently occurring, nor will it likely ever occur in the future. Likewise, pessimistic forecasts of ecosystem degradation and collapse fail to match observed trends showing widespread enhancement of planetary vegetation. These and other phantom pillars that form the foundation of all climate alarmist claims are merely the conceptual constructs of woefully inadequate computer climate models. Real-world observational data, in contrast, do not support a catastrophic or even problematic view of global warming. Consequently, I implore each of you to honor science and the scientific method by voting in affirmative for our resolution tonight. Thank you.
Thank you. So let's get back to the resolution. The resolution claims there is little or no evidence that global warming poses any dangers to us. Now, Craig's given you a lot of claims of things that would show that, but he hasn't shown that there's little or no evidence. I've shown you that there's a tremendous amount of evidence. In fact, next slide coming, we're in the wrong place there. The one that's the summary. What I've shown you is that we have more than 160 years of scientific study of the greenhouse effect and planetary warming, establishing that basic physics of the problem and showing that it is quite real and that carbon dioxide is the driver. We've got more than 50,000 peer-reviewed publications in just the last 2 decades alone. This represents the work of thousands of PhD scientists supported by many more students. Research has been conducted under the auspices of every major university, NASA, NOAA, the Department of Defense, Department of Energy, and equivalents in virtually every other nation. Just this year, in January, the Department of Defense and the National Intelligence Agencies released their National Threat Assessment, in which they said global warming poses significant danger for our society. The National Climate Assessment put out in 2017 under the Trump administration said the same thing. Hundreds of pages of research backing the fact that we have a real problem. Craig wants you to believe that all this vast amount of evidence doesn't count. That's the only way he can say little or no evidence. But as I've noted, the only way it could not count would be if all these scientists don't know what they're talking about, or there's some sort of mind-boggling conspiracy of all these scientists, universities, government agencies, and as I showed you, including Margaret Thatcher and me. The resolution is factually false because the evidence is real, and it overwhelmingly shows that human-caused global warming poses a danger to the future of our civilization. But I want you to do more than just vote no. I want you to leave here ready to look up for yourself and understand that Craig, he seems like a nice person, but he is running a misinformation campaign deliberately with the attempt to try and fool you and the rest of the public into believing that all these scientists are out somehow to get you and to destroy your lifestyle. They're not. And in fact, we didn't get a chance. I was hoping it would come up during the Q&A, but I'll tell you what, I'm a free market evangelist, and I believe if we charge the true cost of our fossil fuels, including what they do to our health, with their pollution, the cost of national security, of protecting the oil supply, of all the money we've given terrorists by buying fossil fuels for them over the years, if we included all those costs, we would find that switching to any other source, whether it's renewables, nuclear, anything else, or even sequestering the carbon from the fossil fuels, would be far cheaper. We'd be getting energy far cheaper than we're paying today. We are actually overpaying for our energy right now because we let the fossil fuel companies just dump their stuff in and make all the rest of us pay for it. By the way, there's a word for that, where somebody does stuff and makes everybody else pay. Socialism. We have a socialist energy economy today. And if we recognize the reality of this problem, we can solve it in a way that promotes the free market, stops the socialist spread of the energy market, has more personal freedom for all of us, and at the same time benefits us with more cleaner and cheaper energy, leading us all to a brighter future. Now, we live in a time when we often hear about how polarized we all are, but I want to tell you what we all agree on, from the most extreme left to the most extreme right. We all want a better world for our children and grandchildren. So I'm going to close with an exercise designed to personalize this issue. I want you to imagine that you have to write a letter and put it in a time capsule for 50 years for your grandchildren to open, at which point they will be on average about the same age you are today. And here's what I want you to write. Dear grandchildren, as I write this in 2019, people are arguing about whether global warming is a real problem, and if so, how serious it will be for you when you are my age. I have examined the evidence, and I have decided to fill in your decision. Hope your world is a good one. Love, You. What are they going to think about the actions that you took today when they read your letter in 50 years? We know Craig is going to say he wants to keep the experiment going of dumping more carbon dioxide in the atmosphere because he thinks it's going to be good for us. I don't think that's the case, and I hope you will imagine writing a letter to your grandchildren that will make them proud of how you helped us all work together to solve the problem of global warming and build a better future for all of us.
Well, we want to open the voting, the final vote. So please vote on the resolution, yes, no, or undecided. There is little or no rigorous evidence that the carbon dioxide is causing dangerous global warming and threatening life on the planet. Meanwhile, while you're considering the vote, go on our website at sohoforum.org, and you'll find monthly debates scheduled through December. Next month, we're going to have a debate about food, and the resolution is going to read something similar to what this resolution this evening read. It will be, there is little or no rigorous evidence that vegetarian, vegan diets are healthier than diets that include meat, eggs, and dairy. That will be Nina Teicholz defending that resolution against nutrition expert David Katz. Wow, we've got quite a lively audience this evening. Okay, well, I won't detain you. It looks like we have the final vote. Thank you, Jane. The resolution, the yes vote on the resolution that there is no evidence that's causing dangerous global warming. It began at 24%. That was the pre-vote. The resolution, yes, at 24%, and it went up to 46%. So it gained 22 percentage points. That's the number to beat. The no resolution started at 29%. It went up to 41%, went up 11 points, and so the Tootsie Roll goes to Greg Idso. Congratulations to you both.